Hello, welcome everyone to Northern's Craft. So today doing the daily thermodynamics problem walkthrough. So let's today talk about the concept of molar mixture. Okay, molar mass of the mixture. Finding the way of molar mass of the mixture and the partial volume of the partial pressure and partial volume of the formula of partial pressure. Let's understand with the example only. Okay. But before doing it, I want to show you the formula of molar mixture of the molar mass mixture, how to find it. So the formula for it is molar mass of the mixture will be given as mole fraction of 1 into its molar mass plus mole fraction of second element into its molar mass plus mole fraction of third element into its molar mass and dot. So this will be the molar mass of the mixture's formula. Okay. And about the partial pressure, we will understand it with the example only. So but if you can do this problem by yourself, you have to do it by yourself, since it will make you have practice. So that's why I will say I will wait for 5 seconds to pause it and try to solve it with yourself. 1 2 3 4 5. Okay, then let's do the problem. So the question asks for an ideal gas mixture consists of 0.1 kg of oxygen, 1 kg of carbon dioxide, 0.5 kg of helium. The ideal gas mixture is maintained at 100 kilopascal, 27 degrees Celsius. Take molar mass of oxygen is equal 32 kg per kilomole. CO2 is 44 kg per kilomole, and helium's molar mass is 4 kg per kilomole. We need to find the first question asks for, we need to find the molar mass of the mixture. So this is the formula. So the given things, we need to write the given. What are the given things? So first given thing is we can see we have given as 0.1 kg of oxygen. So given mass of oxygen is 0.1 kg. Given mass of carbon dioxide is 1 kg, and given mass of helium is 0.5 kg. The ideal gas is maintained at the temperature pressure of 100 kilopascal and temperature of 27 degrees Celsius. As we know, in thermodynamics we can take in Kelvin, so this will be 300 Kelvin. Formula is 27 plus 273 Kelvin, 273. So this will be your conversion of Celsius to Kelvin. So given molar mass are also given as, molar mass of oxygen is given as 32 kg per kilomole, and molar mass of CO2 is given as, molar mass of CO2 is given at 44 kg, 44 kg per kilomole, per kilomole. Hope you are writing the solution with me if you haven't solved it. And molar mass of helium is given 4 kg per kilomole. So for finding to solve the molar mass of the, to find the molar mass of mixture, so there are three elements. First we need to find the mole fraction of the first element, then the second, then the third, then multiply it and sum it. Okay, so we know the formula of mole fraction, which is equals to number of moles of O2 divided by total number of mole, total mole. And similarly the formula for CO2 mole fraction will be number of moles of CO2 divided by total number of moles, plus similarly of that of helium will be total number of mole. So now the we know the formula. We take the given mass, which is 0.1 kg, as already written over here, divided by the molar mass, which is 32. So after dividing it, we'll get our value. So this will be is equal to 0.003125 kilomole. Okay, and molar mass of CO2 will be 1 kg upon is given as 44. So this is going to be 0.02273 kilomole. And molar mass of helium will be 0.5 upon 4, which is going to be 0.125 kilomole. And total mole will be equals to O2 plus number of mole of CO2 plus number of mole of helium, which is going to be equal to 0.150855. So we found this. Now we will find the mole fraction. Okay, now let's find the mole fraction of it. So now mole fractions formula for O2 will be, our given value is O2 divided by total. So we found 0.0003125. If you are not writing and just seeing, then you will not understand. You need to have a pen and paper and write the values with yourself and calculate. Then only you will understand. Otherwise, just watch how I am doing. So then total we have calculated 0.855. Here this value will be equal to 0.0207. Similarly, the value for CO2 will be, our value of CO2 will be 0.0207. Okay, not 2273 whole divided by total 0.150855, which is going to be equal to 0.1507. So this is going to be equal to this, and then the value mole fraction of helium will be, as we have calculated, 0.125 kilomole divided by total number of kilomoles 855, which is going to be equal to 0.828. So we found it like that. Now simply put it in the formula of a molar mixture, which is going to be equal to x of O2 into m of O2 plus x of CO2 into m CO2 plus x of He plus He, which is going to be equal to, the first value is 0.0207 into of MO2, which is given as 32, plus of CO2 0.1507 into molar mass is given as 44, plus helium's given as 4 kg into not 4 kg first, which will multiply. Then otherwise, if I do like that, you guys are going to get confused. So now solving this all value, we will get 10.7 kg per kilomole. So this is a solution of molar mixture's value, this value of molar mass of the mixture. Okay, this is the value of molar mass of the mixture. Molar mass of the mixture. Actually, let me see. Okay, molar mass of the mixture. Actually, yes, yes, it's going to be in kg, since kilomole is cut, no. Yes, so 10.607 kg. This is the molar mass of the mixture. Now the second question asks for volume of the ideal gas of the mixture. We need to find the volume of the ideal gas of the mixture. Okay, so this thing is simple. No, for finding the volume of the ideal gas of the mixture, we know the formula simple of ideal gas equation, which is for the mixture, it will be pressure of the mixture into volume of the mixture is equal to number of moles in the mixture into universal gas constant into temperature of the mixture. So we need to find this, as question asks for volume of the ideal gas of the mixture. So this will be simple. Place it over here, and m r dash tm whole divided by pm. So molar mass, this we found the total number of moles sum already in, which is 0.15085, and we know the universal gas constants value 8.314 into we know the temperature, which is 300 Kelvin, whole divided by pressure of the mixture is 100 kilopascal. After calculating, you will get the value of uh, uh, 3.7626 meter cube. This is what you're going to get. Volume of the mixture is going to be this. Find from the ideal gas equation. Okay. So now the third question asks for partial volume of oxygen in the ideal gas mixture. We need to find the partial volume of oxygen in the ideal gas. So here comes the concept of partial gas. Okay. So the thing is simple, no? Like uh, this is the container. Understand it like this. Okay. This is the container, and there are three gases: gas 1, gas 2, and gas 3, which is oxygen, carbon dioxide, and helium, with the pressure PM, no, and temperature TM, and volume VM. Now, when we separately see, partial means like when we see separately, as you study partial differential equation as well. No, we only talk about the specific value. So when we talk about the gas 1, okay, partial mixture of the pressure will be remain same, and temperature of the pressure will remain same, but volume will change, since we are taking only the one gas from here, but its pressure will remain same and temperature will remain same, but volume will change. Okay, you need to keep in mind this. Now let's solve it. The question asks for partial volume of oxygen in the ideal gas. We need to find the partial volume of oxygen in the ideal gas. So we know the simple formula. Previously we have done PVM VM is equal to NT, total number of moles, universal gas constant, in temperature. Pressure will remain same, volume will change, which is going to be equal to number of moles of 1, universal gas constant, and temperature will remain same. So now just like dividing equation 1 and 2, we will get VI1 divided by VM, which equals to NT upon N1 upon NT. So now we have to find the value of VI1, which is N1 upon NT into VM. Here we are finding for oxygen partially. So N1 upon N2 is nothing but the mole fraction of oxygen into volume of the mixture. So mole fraction of the mixture is we have already find of the oxygen, it is going to be 0.027, and the volume of the mixture we have found it, and volume of the mixture we have already found it, which is 3.7626. In the question number 2 we have found this value, and this question number 1 we have found it. Now multiply it and you will get the partial volume of the oxygen in the ideal gas, which is going to be equal to 0.07788 meter cube. This is going to be the ideal gas partial volume of the oxygen. So now seeing the last question, which asks for partial volume of the partial pressure of the helium in the ideal gas mixture. You don't need to do anything. If you don't understand this all stuff, no, you just need to remember this formula. Okay. Similarly, for the helium, partial pressure will be equal to, following the same thing, is going to be equal to mole fraction of the helium into the pressure of the mixture. So this is the formula for partial pressure for the helium. So mole fraction of the helium is 0.8286 into pressure of the 100 kilopascal, which is going to be 82.86 kilopascal pressure of the helium. So we have solved all the questions of this for the question this question asked for. So first we have first we started from here. We have seen what is asking. Given value we have written, and we find the mole fraction of each element, and then multiply it with the molar mass, and we found the molar mixture, and then we found the volume of the mixture, and then we found the value of the partial volume of the mixture, and partial pressure also we found. Thank you for watching this video, and get ready for the next question in the next video. If you like it, please subscribe my channel, and if you have any doubt, ask in the comment section.